Hi, today I'm looking at the DHT11, which is a cheap temperature and humidity sensor. They're not super accurate, but they are very cheap and easy to use. They're digital sensors, so if you use it with an Arduino or anything else, you communicate with it digitally using a simple little protocol, and you don't have to measure resistance or voltage or anything like that. There's a couple different versions of it. This one is the basic version. The pinout is +5. There's a single data line, one line that's not connected, and then the ground. There's also a 3-wire version that comes in the little Arduino kits and things like that. This one is backwards, so watch out for that. Has ground and then the data line and then +5. So let's take a look at how to use it with an Arduino. Okay, so here's a look at how the DHT11 communicates. You take one pin for the data pin, and you start out with the pin sending an output to the DHT11, and it goes from high to low and back to high, and that triggers the DHT11 to send a response. So you switch your pin back to input, and it sends about 40 bits of data with the humidity, the temperature, and a checksum bit, and then you switch it back and you're finished. Fortunately, we don't have to do all of that manually because there are several good libraries for the Arduino. If you look at the library manager on the Arduino IDE and search for DHT, you can see there's a few choices. Some of these support other sensors. There's a DHT12 that's slightly more accurate and more expensive, but I'm using one called Simple DHT, and here's the example code that came with Simple DHT. All I've done is changed my DHT11 pin here to 5 because I've hooked my DHT11 to pin 5, and it's just going to read the humidity and temperature into these two variables by sending pointers to them, and it's going to print them on the serial monitor. I've actually modified the code a little bit for my purpose and added an LCD screen, so instead of the serial monitor you'll be able to see it on an LCD. And let's try that. Okay, so here I've hooked one up to a simple Arduino circuit. We've got the +5 here. We've got the data line, which is green there, going over to, I think it's the D5 pin on my Arduino Nano, but any digital pin would work fine. I have the ground line going to ground. There is also a resistor here. It's a yellow, violet, red, which is 3.7K. That's a pull-up resistor that connects the data line to +5. That's just to send a high signal to the Arduino when there's nothing coming from the DHT11, so you avoid weird random errors coming from floating inputs. I've also added some simple code to the example program for the DHT11 that drives this LCD display, just so that I don't have to show a computer screen here. So let's turn it on and see what we have. Okay, so I've got 77 degrees Fahrenheit in here, 14% humidity. That may sound like an error, but I do live in the desert, and it really is that dry here. So here's the same circuit using the little 3-wire version that's on its own circuit board. I've hooked up the ground and the positive wires, which are in the opposite places as the other one, and the data line in the middle. And I've taken out the resistor because this little board has a resistor built in. And as you can see, it works just the same. By the way, here's one thing to watch out for. You might have noticed a delay of 1500 or 1.5 seconds at the end of my loop in my code. There's a reason for that. If you try to sample the DHT11 too often, it'll start to give you errors. Here I've set it to 1000 or a 1-second delay, and as you can see, it's working every other time, but then half of them are ending up with errors. So if you see an error like that, or if you get a weird reading like -999 degrees, That probably is because you are trying to read it too often. So you either need to include a big enough delay or check for that error and make sure you only display the valid numbers when you program the DHT11. So that's the DHT11. It's a simple, cheap temperature sensor. It is not the most accurate temperature sensor. I believe it's plus or minus 2 degrees Celsius. So if you need something more accurate than that, you'll want to look elsewhere. But if you just need a simple little sensor that's easy to talk to, doesn't require much code, and can also do humidity, this is a great little sensor to use.